Okay, we're going to talk about the growth hormone and how it is supposed to properly work in the human body. Okay, so we all know that the hypothalamus, the lovely hypothalamus, is the center that controls the release of hormones, particularly from the anterior pituitary, because the anterior pituitary houses majority of the hormones. Posterior pituitary only houses the antidiuretic hormone and the oxytocin hormone. You'll learn that later. Okay, so there's always a stimulus before there is an effect. Stimulus can be time of day. It could be while you're sleeping, moving around. It could be age. It could be nutrient levels in the body, what you eat. Are you stressed? And or are you exercising? Okay? So you have a stimulator. After a stimulator is always a receptor. So your body stimulates something. It sends a signal up to your brain, and your brain sends out a receptor. Receptor just so happens to be in the hypothalamus, and it says, hey, we need to release some type of hormone, right? So, right here. Now, this is a receptor. Hypothalamus is responding, so we're going to knock it down. Inferior to the hypothalamus is the pituitary gland, which has the anterior pituitary side, which is the largest side, and the posterior pituitary side, which my dogs ate off. And then you have the hypothalamal hypoglycal tract, and then this should be the portal system. Okay, so once the hypothalamus tells your pituitary gland what's going on, what nerve signal has been sent here, it will release a specific hormone. Mine just so happens to be the growth hormone. All right, so it's going to instantly go to my anterior pituitary because that's where my growth hormone is stored. All right, so the growth hormone releasing hormone drives to the hypothalamo hypoglycal system. From there, it moves down to the liver. From the liver, it goes through the liver, and this is what I came up with. I could be wrong, but I feel like it goes through the liver through vascular transport. I'm not sure. Correct me if I'm wrong, but this is just me learning on my own. And then what comes out of the liver, it releases another hormone, which is called hormonal stimulation. One hormone releases another hormone. It releases the insulin like growth factor into the blood. Now, growth hormone still comes to the blood also, but when it filters through the liver, it releases the insulin like growth hormone factor. It goes in the blood. Now, this is my blood vessel. Blood. In the blood, we already have all these type of nutrients floating around. So, of course, we got glucose, amino acids, fatty acids, all that good stuff. Okay. So these two hormones meet up in the blood with your nutrients. And they're like, hey, we got to do something with this hormone. And you know, hormones travel through the blood until it makes it to its target cells or receptors. So, 3 target cells. We got adipose connective tissue. Once these hormones, the growth hormone and the insulin growth like factors, make it to this adipose connective tissue, it starts to break down the triglycerides and it decreases the growth of triglycerides. When it makes it to the liver tissue, it affects glucose. So it increases glycogenosis and glycogenesis. So the glycogenesis decreases. So the make of glucose decreases. These are my cells, muscles, and bones, and those all obtain amino acids. So amino acid intake causes protein synthesis. That's the make of protein, the regeneration of protein, and stimulates cellular division to generate energy, right? So we do all this in the blood. The blood makes it to its, I'm sorry, I hope you can see this. The blood makes it to its tissue or organ. And then it goes to the net effect. Protein synthesis, which we talked about, cellular division, and all differentiation occur in the cartilage, bone, and muscle. This releases stored nutrients into the blood. This side is inhibition. Then you have increased levels of the growth hormone and the insulin growth factor hormone. It stops the release of the growth hormone from the hypothalamus. This also does the same for the release of the growth hormone in the anterior pituitary. So once your nerve sends a signal to the hypothalamus then sends a signal to this anterior pituitary gland and says, hey, let's release this growth hormone to the liver and the blood. Through the liver, it uses vascular transport and it releases another hormone, IGF, through hormonal stimulation, goes into the blood, affects all these nutrients that's in the blood, and leaches on to one of these organs or receptors, and it does its due diligence. And then once it sends that signal back up and says, "Hey, that's enough. Let's stop." If you have an inadequate growth hormone production in children, it causes dwarfism, and if you don't have enough, it causes dwarfism. If you have too much, it causes giantism in children. And then it can happen in adults too, people that have already hit adulthood. It's called, I don't know if I'm pronouncing it right, acromegaly. So it's just certain bones may enlarge, and it could cause some real complications going forward. So, hey, I hope you liked my video, and I hope I made sense. And have a good day, and I hope your growth hormone is just the hormoning. Bye.